Welcome to our channel. Today we're diving into the dark and mysterious corners of the universe. Get ready to be amazed and a little bit terrified by these mind-blowing facts about the cosmos. I'm your guide from Universal Now, and together we're about to embark on a journey that will stretch your understanding of reality itself. The universe, in its infinite grandeur, holds secrets that are both profoundly beautiful and unsettlingly strange. From the very fabric of space-time behaving in ways that defy everyday intuition, to colossal structures that dwarf our wildest imaginings, we're going to explore phenomena that challenge our place in the cosmos. So buckle up your cosmic seatbelts, because the ride is about to get wild. We'll be looking at things that can stretch you into spaghetti, invisible forces that govern the fate of galaxies, and even the possibility that our entire universe is just one among many. These aren't just abstract concepts. They are the realities that astronomers and physicists grapple with every day. They paint a picture of a universe that is dynamic, evolving, and often downright bizarre. Prepare to have your mind expanded, your curiosity piqued, and perhaps to feel a little smaller in the grand cosmic scheme of things. Our journey today will cover 10 such mind-bending realities. Each one is a testament to the universe's capacity to surprise us, to humble us, and to inspire us to keep looking up. We'll touch upon the very beginning, the ongoing evolution, and the potential ultimate fate of everything we know. So, if you're ready to confront the universe in all its perplexing glory, then you've come to the right place. Let's begin our exploration of these truly mind-blowing facts about the cosmos. The universe is expanding, not like an explosion, but the fabric of space-time itself is stretching. Think of it like dots on an inflating balloon. They get further apart. Edwin Hubble discovered this in the 1920s. The expansion is accelerating, driven by dark energy. Some parts of the universe are receding faster than the speed of light. All right, let's venture into one of the most iconic and terrifying objects in the cosmos: black holes. These are regions of space-time where gravity is so incredibly strong that nothing, not even light, can escape once it crosses a boundary called the event horizon. They are the ultimate cosmic vacuum cleaners, formed from the collapsed remnants of massive stars. Now imagine, hypothetically, you were to venture too close to a black hole. The term scientists use is spaghettification, or the tidal effect. This occurs because the gravitational pull of the black hole would be significantly stronger on the parts of your body closer to it than on the parts farther away. If you were falling feet first, your feet would experience a much stronger pull than your head. This differential gravitational force is what we call a tidal force. Eventually, the tidal forces would become so immense that they would overcome the molecular bonds holding your body together. You would be literally torn apart atom by atom. Now, let's talk about a cosmic enigma, a gravitational anomaly that has puzzled astronomers for decades: the Great Attractor. Imagine something so massive, so gravitationally influential, that it's pulling not just our own Milky Way galaxy, but our entire local group of galaxies, and even the larger Virgo supercluster towards it. This isn't a gentle tug. We're talking about a motion of hundreds of kilometers per second, a significant cosmic velocity, all directed towards a specific region in the sky. The mystery of the Great Attractor lies partly in its location. It's situated in the direction of the constellation Norma, behind the plane of our Milky Way galaxy. We tend to think of planets as cozy companions to stars, dutifully orbiting their stellar parents in well-defined paths. Our own solar system is a perfect example, but the universe, as always, has surprises in store. Imagine planets that are entirely untethered, drifting alone through the vast, cold darkness of interstellar space without a star to call their own. These are rogue planets, also known as interstellar planets, free-floating planets, or orphan planets. They are the cosmic nomads, wanderers in the galactic wilderness. How do these planets come to be? There are a couple of leading theories. One possibility is that they form in the same way as other planets, within protoplanetary disks around young stars, but are then ejected from their home systems. This could happen due to gravitational interactions with other larger planets in the system, or perhaps due to close encounters with other stars, or even the supernova explosion of their host star. These planets are the unfortunate victims of such gravitational disruptions. Let's turn our gaze to the very early universe. to the faint afterglow of the Big Bang, known as the cosmic microwave background, or CMB. This radiation permeating all of space is remarkably uniform in temperature, around 2.7 Kelvin. However, remarkably uniform doesn't mean perfectly uniform. There are tiny temperature fluctuations, hot and cold spots, which represent the seeds of future cosmic structures like galaxies and galaxy clusters. But among these fluctuations, there's one that stands out, the CMB cold spot. It's an unusually large and unusually cold patch in this ancient light. Discovered by the WMAP satellite and later confirmed by the Planck satellite, the cold spot is a region in the constellation Eridanus that is significantly colder, about 70 microkelvins colder than the average CMB temperature. While that might not sound like much, on the scale of CMB fluctuations, it's a major anomaly. It's much larger and colder than predicted by standard cosmological models. Prepare to confront a rather humbling reality. Everything we can see, all the stars, planets, galaxies, all the ordinary matter made of atoms, accounts for only about 5% of the total mass and energy content of the universe. The other 95% is made up of two enigmatic components: dark matter and dark energy. These substances are dark not because they are necessarily black, but because they do not interact with light or any electromagnetic radiation in any significant way, making them invisible to our telescopes and direct detection methods so far. Their existence is inferred solely through their gravitational effects. Let's start with dark matter, which makes up about 27% of the universe. We know it's there because galaxies rotate much faster than they should if only their visible matter was providing the gravitational glue. Stars on the outskirts of galaxies are moving so rapidly that the galaxies should fly apart, but they don't. There must be extra, unseen mass providing the additional gravity needed to hold them together. Imagine the most powerful explosions in the universe since the Big Bang itself. We're talking about gamma-ray bursts, or GRBs. These are incredibly energetic flashes of gamma rays, the highest energy form of light originating from distant galaxies. For a few fleeting seconds, or sometimes minutes, a GRB can outshine its entire host galaxy, releasing as much energy as our Sun will produce over its entire 10 billion-year lifetime. These are not subtle events, they are cosmic cataclysms of unimaginable power, true behemoths of destructive capability. There are two main types of GRBs: short-duration bursts lasting less than 2 seconds and long-duration bursts lasting longer. Short GRBs are thought to be caused by the merger of two compact objects, like two neutron stars or a neutron star and a black hole. As these incredibly dense objects spiral into each other and collide, they unleash a focused beam of intense radiation. We've talked about the universe's expansion and the mysterious dark energy driving it. This leads us to ponder the ultimate fate of the cosmos. If the universe continues to expand and accelerate, as current observations suggest, then one of the leading theories for its end is a scenario known as the heat death, or the big freeze or big chill. It's a rather bleak but scientifically plausible outcome based on the laws of thermodynamics, particularly the second law, which states that entropy, disorder in a closed system, always tends to increase. In this scenario, the relentless expansion driven by dark energy continues indefinitely. Galaxies become increasingly isolated from each other, eventually receding beyond each other's cosmic event horizons. Within each isolated galaxy, star formation will eventually cease as the available gas and dust are used up. The existing stars will one by one exhaust their nuclear fuel. Smaller stars like our Sun will become white dwarfs, slowly cooling down. More massive stars will explode as supernovae, leaving behind neutron stars or black holes. Now, let's turn to a question that has captivated scientists, philosophers, and science fiction writers for generations. Are we alone in the universe? Given the sheer scale of the cosmos, hundreds of billions of stars in our Milky Way galaxy alone, and hundreds of billions, perhaps trillions, of galaxies in the observable universe, it seems statistically improbable that Earth is the only planet harboring life, let alone intelligent life. This line of reasoning leads directly to the Fermi paradox, named after physicist Enrico Fermi, who famously posed the question, where is everybody? The paradox arises from the apparent contradiction between the high probability estimates for the existence of extraterrestrial civilizations and the utter lack of observational evidence for or contact with such civilizations. Consider the Drake equation, an attempt to estimate the number of active, communicative extraterrestrial civilizations in our galaxy. While many of its terms are highly uncertain, even conservative estimates can yield a significant number of potential civilizations. So, if they exist, why haven't we heard from them? Why haven't we seen any unambiguous signs of their technology, like megastructures, interstellar probes, or powerful communication signal? For our final mind-blowing fact, let's push the boundaries of what we even consider the universe. What if our cosmos is just one bubble in a vast collection of universes? This is the multiverse concept. Emerging from string theory, eternal inflation, and quantum mechanics, it challenges our definition of existence. One way a multiverse could arise is through eternal cosmic inflation. Some regions stopped inflating, forming bubble universes, while others continue to inflate eternally. The universe is a place of endless fascination and profound questions. From black holes to dark matter and the Fermi paradox, the cosmos constantly challenges our understanding. It's a dynamic, evolving universe. Thanks for watching. Like, subscribe, and hit the bell icon for more. Keep exploring the magnificent universe we inhabit.